Hello and welcome to the last module in infrastructure provisioning with System Center 2012 R2. My name is Kenan Owens and I am a Senior Product Marketing Manager here at Microsoft, focusing on Windows Server and System Center and how we can handle virtualization, create the clouds, and how we expand that clouds out to your server provider and Windows Azure. In this last session here, we're going to be focusing on the day-to-day operations within managing your private cloud environment. So we're going to focus on not only that, but also talk a little bit about the underlying physical architecture that you need when you create this VMM infrastructure to provide these cloud resources. In the first two videos, we talked about things like how to deploy your compute, storage, and networking underlying fabric resources. In the second video, we talked about how to take those physical resources and build your cloud environments and support multi-tenant environments. And here we're going to talk about some of the day-to-day operations, things you're going to have to come across, whether it be optimizing your resources for best utilization to managing those services that your end users or customers are going to be deploying. And then we'll talk about the architecture reference. So when we look at this, the first thing is a customer needs to know, I need to know that I'm using my resources to the fullest. I have a bunch of servers out there. I got a bunch of virtual machines deployed. I want to ensure that those virtual machines are not all sitting on one box, fully utilizing that box, and all my other ones are sitting idle. I want to redistribute these workloads as my needs change. And then I need to be able to handle things like, if I'm not using these physical servers and resources, maybe I can power them down a little bit and save some energy or something like that. So I need to know how all this thing works and how I can fully leverage these physical resources. And to start that off, we do that with dynamic optimization. So within a cluster, whether it be a Hyper-V cluster, a VMware cluster, or a Citrix Xen server cluster, I have virtual machines running on these physical servers. And those virtual machines are going to have different usage patterns. And sometimes I'm going to pass or surpass an optimization threshold on one of these servers, just because of the utilization that's happening during the day, a week or month, or whatever is happening. Maybe everyone's logging into that one server at the same time, and it's just going to start maxing out the VM usage on there. Well, if that's the case, I need to rebalance the workload across all of these different servers to be able to handle that change in resources. Now, once I've rebalanced these virtual machines, moved them around a little bit, things run and everything might be going okay until a little bit later on when another one of these servers just starts utilizing all those physical resources. Again, once it passes that optimization threshold, I can rebalance the workload across these different systems and again, get a proper separation of these virtual machines in such a way that they're going to be fully leveraging all of the resources, and no one server is going to be starved for resources. No one virtual machine will starve the other virtual machines or something like that. So dynamic optimization really gives me the ability to rebalance these workloads on the fly. It also gives me the ability to handle spikes and changes in resources where I don't have to be looking at all these different servers every day. I can just let dynamic optimization rebalance the workload. Now, the cool thing about dynamic optimization is that if you look at how it handles it, it uses things like live migration to move these virtual machines around. So the VMs are going to stay up and running. They're not going to be paused or anything as I move them from one server to another. I'm going to leverage live migration to do that. I'm going to avoid downtime to the virtual machine because I am using live migration. And I can do this on either a Hyper-V cluster, a VMware cluster, or a Citrix Xen server cluster. In other words, I don't have to only be able to do this with Hyper-V. I can use dynamic optimization across all these different types of clusters. The other thing is that it's going to look at all the different resources that I have. It's going to look at the CPU, the disk, the network, the memory, and it's going to determine where is the best fit for that virtualized environment to rebalance these workloads and use things called like intelligent placement to ensure that when I move all these virtual machines around, I actually gain a benefit. I gain better resource utilization across all my different servers. And we look at the entire cluster. We don't want to take a server that's running at max resources, move it to another server. Now all of a sudden that server is running at max resources, and so therefore we're not gaining any benefit. We're just moving the problem. we'll leave that around and we'll move other things to really rebalance this workload accordingly. And we do it depending on the way you have it set up, either manually, where you can choose, okay, optimize now, and it'll optimize the workflow loads, or automatically. In other words, you can just have it do this over time. And it's not going to do it like every second. In other words, it'll look at the resources that are running. It'll take the weighted average over a 10-minute period, if that's what you have configured and set, and it will rebalance the workloads across there. But it'll only do it depending on how aggressive you set your settings. If I set it for really aggressive, it's going to rebalance so that everything's as even as possible. But if you have it set for moderate aggressiveness, or even worse, or even less aggressive than that, more conservative, then what it's going to actually do is it will only make a change if it's going to have a star level impact. In other words, it's not going to move things around unless it really affects the better placement of all the different virtual machines running across that system. So dynamic optimization helps you enable and handle your ever-changing workloads that you have running on your system. The other thing is that over periods of time, you may actually have too many physical resources for the amount of need that the virtual machines are running. In other words, I may have a 10-node cluster, and I may be running 1,000 virtual machines. But if those 1,000 virtual machines can fit on 3 servers, why have all those 10 servers powered on? So I can leverage power optimization to handle if the workload goes down and I still have enough resources to be able to support that running number of virtual machines. Let me shut down some of those servers. Once I shut down those servers, then I can continue to run there, save the energy in the data center, and then when the workload picks up, power those servers back on and rejoin them to the cluster. So basically, the virtual machine's running, but the workload goes down below a threshold, meaning that the utilization of the servers plus leaves me with enough resources that I can shut down some of these servers and still be below that optimization threshold. If that's the case, I'll move these servers off, I'll shut down that physical host, and I'll just run on the less number of servers. After a while, the workload picks up because of demand, change of date, or whatever, and then all of a sudden, we'll power that machine back on, we'll bring it up, and use dynamic optimization to rebalance the workload across these different systems. So this now gives me the flexibility of turning off some of these servers when I'm not using the resources that are necessary, save some power, save some energy, because a powered off server uses a lot less energy than a idle server. An idle server still uses a lot of energy. So if we can actually shut it down, we can really save some power in the data center, and that might help with how the information and how the resources are running. So again, we're going to look at the different resources. We're going to look at CPU, we're going to look at memory and network and everything, and we will optimize when the resources move below a specific threshold. And we're going to consider the entire cluster. If I have a 10-node cluster, like I said, and all the resources can run on 3 physical nodes, then we will start shutting some servers down. But if I'm going to shut servers down and all of a sudden now I'm going to be above that resource threshold, I'm not going to shut that last server down, because it's going to be too much that I've shut down, which means that the virtual machines will then be starved for action or something like that. I can define when this kicks in. Maybe I only want it to kick in at night and weekends. Maybe I only want it to kick in at lunchtime or something like that. Well, I can specify when that's going to happen. And I can enable it to happen, and I can enable power optimization only when dynamic optimization is set to automatic, because we have to be able to rebalance this workload, especially when that load picks up. And then lastly, I have specific power operations that I can do. So I'm going to use live migration to move virtual machines off of that node. I'm going to ensure that when I do move all the virtual machines off of those nodes that I'm going to shut down to the remaining nodes, that I'm not going to overload those remaining systems. I'm going to ensure that the cluster quorum requirements are going to be still kept. In other words, I'm not going to shut down so many servers that now I don't have the cluster quorum that I need. And we're going to use the out-of-band management connectivity to the server to be able to enable or disable power optimization. So this allows me to help conserve some of the energy that I've been leveraging inside of the data center. The last thing on day-to-day operation is every once in a while things like patches come out, right? So you need to be able to push updates to these servers, these Hyper-V nodes, without affecting the running virtual machines on those systems. So within Virtual Machine Manager, we allow you to do host updating, and we basically allow you to create a baseline so that you know which patches are available and those patches that you want to ensure each of these hosts are set up against, and then we'll check these different Hyper-V hosts against that baseline. If they have all the patches, great. They'll scan it. If they have the patches, they're up to date, perfect. But if they're not up to date, if new patches came out and you want them pushed down to the system, these machines will now be out of compliance. You'll say, I want to be at this baseline, they're below it, so now you need to bring them up to that compliance. And we do that by remediating. And at that point, we will do an orchestrated method of taking these physical servers within a cluster and bringing one down at a time until we bring all of these systems up to date. That way, none of the VMs will go down, but we'll still have an organized way of bringing these hosts up to the current baseline. So think about it this way. I have the VMM server, it talks to a WSUS server, and that's where I know which baselines are available to me. I create my baseline, and I set up which of these updates and patches are important to me, and I set them up as a baseline. Once I've set them up as a baseline, I then scan all the different individual servers. After I scan these servers, I notice that these servers are not in compliance, so I'm going to update each of the individual host servers in an orchestrated fashion, moving all the VMs off of one host, removing it from the cluster, doing the update to it, rebooting it if need be, bringing it back into the cluster, and then doing the next one. And by putting the next one in maintenance mode and pushing all the host VMs off of that host, I can then pull it from the cluster, reboot it after I've updated and patched it, and do that down the line. Now the thing is, I may want one of these hosts or a certain host I don't want to update this way, and I may want to make an exception of that. And I can create these exemptions so that this host is exempt from this upgrade operation. It's always going to be up and running. It gives me now that flexibility of doing host level management in an orchestrated way without bringing down the virtual machines that are running within this cluster. Now you may say, well, there's Configuration Manager and there's VMM to do these updates. And in fact, there's also this thing with Windows Server 2012 called Cluster Aware Updating. Well, how do they all fit together? Well, you pick Virtual Machine or Config Manager, and really it depends on what you're trying to do. If you're treating your Hyper-V host that VMM manages as a clustered resource, as an appliance, then you want to use Virtual Machine Manager for host level management. If it's another physical machine that you want to manage just like your SQL servers or something else, then you can use Configuration Manager. If you want a protective way of patching the OS so that I don't bring down the virtual machines within a cluster, probably Virtual Machine Manager is the way to go, because Virtual Machine Manager, you can create that baseline, you can bring those virtual machines up and down and that type of thing. With Configuration Manager, you got to do a lot of orchestration around that to get the same type of capability. But you could also do it with Cluster Aware Updating. So you have different choices, we know that, and depending on how you're treating these Hyper-V hosts, probably if you're treating these Hyper-V hosts as appliances, which a lot of customers do, then using Virtual Machine Manager as that one-stop shop for managing those hosts is the way to go. But you have different choices just in case you need them. And you can use these things in conjunction with each other. You could use Configuration Manager for things like desired configuration management against the host, make sure settings like whether or not terminal services is enabled or something like that on the host. You can do all that via Configuration Manager. You can use Virtual Machine Manager for doing your cluster updating, or you can use Cluster Aware Updating for that, but you can use Virtual Machine Manager for your bare metal deployment. You have choices, you have options. Use the one that's best for you and your environment. Now, that's day-to-day operations and management of the different the underlying physical host environment. But we also have these things called services, and we've talked about them in the first two videos, where when I deploy an environment, I deploy usually an application is not just one virtual machine, but it's usually multiple tiers of virtual machines, and each of those tiers may have one or more virtual machines inside of it. And so I need to be able to create a way to have this combination together inside of everything and pulled together, and VMM provides that flexibility with the service template model. So if we look at what a service template model is, it's basically the following. It's the ability for you to create multiple tiers, and each one of these tiers is a virtual machine template. And that tier has specific components associated with it. It has a hardware profile and a VHD, so it has, the hard drive of the VM, and that's a VHD image that's usually stored in the library. It has an OS profile, what's the domain credentials, what's the information inside of there. And with System Center 2012, with VMM 2012 and beyond, we've added the capability of presenting an application profile, whether that be for a web tier, an MS deploy package, whether it be for an application tier, a server app v package, or whether it be a data tier and a SQL DAC pack for defining that configuration of that database. You have the ability in a service template to add that application profile on top of it. You also can specify for each of those individual tiers a scale out type property. In other words, I may have a web tier that has 3 VMs that when I deploy initially, I wanted to have 3 VMs in a load balanced web farm. Well, I want this thing to scale out to 10 virtual machines depending on the utilization. So I can create a scale out policy that says minimum of 3, maximum of 10. Let's start with 3, and then you can scale out as need be. Or I may want to say that this is only a single tier VM with 1 virtual machine, and that's all it is. So I can specify those different policies on a per tier basis. And all that information is stored in a service template, and that service template is stored inside the VMM library. Now, inside each of these tiers, we talked about the web tier, the application tier, and the data tier. Well, if we look at the data tier, we can create these things called SQL profiles. And a SQL profile allows me to specify for SQL Server 2008 R2 or for SQL Server 2012, what is the configuration, security mode, and all that information for that SQL Server environment. So when I create a virtual machine template for the SQL Server, or I create the SQL tier within my service template, I can go through the configuration of that VM, and I can specify all the different information necessary to deploy that SQL environment, all the way up to and including things like the SQL database configuration through the DAC pack. When I deploy this environment, I need to have a VHD file with sysprep SQL already on top of it, and then I can use that to deploy the different SQL servers, and it will then do the SQL configuration, set the SA password, and all that other stuff, exactly how you would specify and set up an existing SQL environment. The other thing is I can deploy application servers using server app v. And when I deploy applications to a shared platform, I may want to or need to deploy either just a standalone virtual machine, or I need to deploy that SQL to an existing physical server that's already running SQL, or I may want to deploy a virtual machine as part of a cluster for that tier. Well, inside of VMM 2012 SP1, we have the ability to deploy these web environments. I'm going to deploy a web tier environment or a web server with SP1, System Center 2012, Virtual Machine Manager SP1 or R2, or SQL DAC packs. And I can also specify when I deploy these services, I can specify configurable settings that can be created at deploy time. So in other words, I may have a set of servers that I'm deploying, and maybe one of the information I need when I deploy this set of servers is a website name. Well, I can make that as a configurable variable that I can plug in and deploy at deploy time, and then when I deploy this server out there, it will ask me what's the server web name, and I'll be able to type that in, deploy the service out there, and when the service deploys, it will now have not only the base configuration that I have, but also all this user configurable information that I set up at deploy time. And that leads me into what are some of the things that we can do with configurable server settings. Well, a lot of things that we can do here is we can specify some values that are configured at deploy time. And to do that, while we're creating these variables or these service templates, we can specify variables using this at variable name at sign parameter. And then it takes all the ones that we have that are called at variable name at, and it pulls them out, and it says when I deploy the service, fill this information in, fill this information in, fill this information in for each of those variables that we've created. I can set up service settings so that they're mandatory, meaning that they have to be deployed. They can be stored as encrypted data. I can even specify a default value. So what this means now is that I have the ability to specify a default value that could be overridden if necessary. And I have several of these predefined service settings that are already available, things like at computer name or at VMID. Those things are already there, make it easy for me to use, but I can also specify my own inside of the service template. What we've added with 2012 SP1 and R2 is the ability to execute custom scripts within this service instance. So what this means is that now I can specify things like run as account, script restart behavior, if it failed and I want to restart, what do I do? As well as logging properties inside of the service template itself. So as I create a service template and I create the pre and post install commands that I'm going to use when I'm deploying these virtual machines, I can run these generic commands that kick off certain tasks or run certain things, and I can do this at multiple different entry points. I can do it at the entire service level. So in other words, I start deploying the service, I want to run a pre-script and I want to run a post-script. Or I can do it at the level for each of the different applications that I'm installing. So if I'm installing a MS Deploy package and then a second MS Deploy package, I can create a pre and post for each of those types of things. I can also do it, specify what it does for deployment as well as for things like updates and those types of things. So there's pre-install, there's post-install, there's pre-update, there's post-update. A lot of different entry points for running these different types of scripts. And this was great for a lot of customers, but a lot of customers, when they were deploying an environment, say a clustered environment, they wanted some things to run one way on the first instance of that node, but then all the other nodes, they wanted to do something a little bit different. So with R2, we added this asymmetric provisioning within that specific tier. So what this means is that a tier will allow us to run one script for the first node of the tier. Like if I'm creating a cluster, it's going to do all the work to create that cluster. But then the second and third and fourth and fifth nodes in that tier, it's not going to go through all the cluster creation, but instead do a cluster join. And that gives me now the ability to have some variability depending on what type of node I'm running against, to ensure that the virtual machines are deployed correctly and that it makes it more simple to do things like create a load balance web server cluster or create a file server or SQL cluster or something like that in the back end. We also have a better way of connecting and scripting that app deployment within the virtual, within the script deployment process. And what this allows me to do now is provide a better or more simple way of deploying virtual machines to handle subsystems like Chef or Puppet, which do a different way of deploying services than we do. And by combining them together and giving you this other type of deployment capabilities within a script environment, you can not only run your generic command executions, as the way of app deployment, but you can also create these script command lines with parameters that will be checked as part of our servicing environment, so that as we deploy these different services or we update them, you can more easily integrate them with your existing Chef or Puppet environment. Now within System Center 2012, with VMM 2012 on R2, we now also support or re-support deploying services to Zen hypervisors. With 2012, we supported deploying services to both Windows Hyper-V, VMware, and Citrix Zen. With SP1, we only supported VMware and Hyper-V, and now we've re-added Citrix Zen Server inside of that environment. So if we look at what a service template is, let's break it down to as one of its most similar or simplest environments, and that is a single tier service template. So service template, basically, if you think about a single tier service template, it's just going to be a VM template, and that VM template could have one or more VMs deployed against it. And it's going to have a hardware configuration, an OS configuration. We also could have an application configuration inside of there. And I can take that template and I can deploy it one or many times. So I take that VM template, I encapsulate it within a service template, and I can deploy one of those, maybe I deploy a second one. Has all the different roles and features that we've enabled. One of the cool things that we enabled within service templates is also that capability or ability to add on and pre-install the existing roles and features that you may want for that particular VM. I mean, how many times have you deployed a Server 2008 server and you needed to have .NET 3.5.1 feature installed? It happens almost every time. So why not I pre-deploy that? And it only happens when it's part of a service template. We'll do these roles and features. We'll also be able to deploy the application package on top of it, whether it's MS Deploy, Server App V, or your SQL DAC pack. But we can deploy multiples of those. And in this environment, that one tiered service has multiple different virtual machines within that tier. Maybe it's a load balanced web tool or something like that. And so I can create this instance, and these virtual machines are set up so that as they're running, if I make a change to the service template, I can then push that change down to the deployed service instances that are on there. I can scale out and everything because this thing is wrapped inside of this service template model instead of being just a bunch of individual virtual machines. So now I've created these service templates. How do I handle the day-to-day management of them? How do I create these things? How do I handle it? Well, we have a service template designer. And the service template designer is something where you basically just right-click, create new service template, or if you have an existing template, you open the designer, and you go through and you basically can just drag and drop those virtual machine templates onto a canvas and then build the connectivity between them, what type of network adapters and those types of things they're connected to, but also do things like add application packages and those types of things if they're not already in the VM template. And so the template designer or the service designer allows me to, with the ribbon, run any of these contextual and important tasks. We just have them straight up there. You can right-click on a particular VM template and do add or whatever. In the designer, it's this canvas that you can use to build this interconnected template from these different VM templates that you have outside of there. And then I can specify service-related properties like what's the scale-out parameters for this virtual machine environment? What's the cost center is going to be attached to? How many of these are going to be deployed initially? What's the servicing order? Do I do this one first or a different tier or whatever? So I have a lot of different properties that I can modify per service tier, and then I can do it at the template level as well. Now, after I've created the service template, I want to deploy it. So I would click on, deploy service template, and through the deploy wizard, I would be able to then see what this is going to look like when it's being deployed, either on the host or on the cloud. In this example here, I have a production cloud, and I'm deploying this multi-tier service, which is going to consist of one backend SQL server, one middle tier server, and 2 web front-end servers. So it shows me these are the 4 VMs that I'm going to create, and they're going to be able to fit on the cloud. I look to make sure that the preview pane will show me whether the service will deploy or not inside of this environment. Do I have enough resources available to me? Is the networking correct? All those different things will show me whether they will work or not. If it doesn't work, it'll give me a yellow a yellow warning, and I'll be able to go up to the refresh preview or the information and find out why it's not going to work. Then, after I've checked to see whether I'm able to deploy there, we have the ability to specify those settings for this virtual machine, meaning that I can look at those customizable parameters. When I do this deployment, I want to ensure that the web server talks to the SQL server. So I need to type in something that I can inject into the web server so it fills out the right parameters or something like that. Well, those variables are here. I type in the different results for them, like the SQL server name, the app server name, whatever it is I need to fill out to deploy this server in this customized environment. And it allows me to specify those at deploy time here. And then after I've done that, I can look at the ratings and find out why it didn't work. And if it does work, I can hit deploy and have it go off and deploy those things. And not only can I do that with Windows guests, Windows virtual machines as guests, but with 2012 SP1 and better in R2, I can do that with Linux guests as well. So this gives me now the ability to create a repeatable deployment of my Linux guests that's automated for things where I can customize things like the password, the computer name, the IP address, the DNS domain name, all these different things. And whereas in a Windows environment we have these pre and post scripts that we have, at least we have the ability to run a run once command inside of that Linux environment. And so that way you have the files you need to be able to run inside of that Linux VM that you've deployed. It can go off, and then through that command you can run all the scripts and do all the work that you need to do to get that thing deployed. And it supports all the different virtual guest operating systems that VMM and Hyper-V support for deploying these Linux guests within a service template. Now, once that virtual machine is deployed, you go to the VMs and services workspace, and you can see the different services that are out there. In the window pane, you can see which services are deployed and which of the individual tiers are there. And of those tiers, you can see which virtual machines are out there. You can perform operations at a service level, at a tier level, or at an individual VM level. I want to start and stop that particular VM, I can do that. I want to restart the tier, I can do that. I want to restart the service, I can do those. All of those different things. I can also view the specific service and tier application settings. So all those custom parameters I set up, or other parameters that are filled out and default inside of there. I can see how they're configured and set up. I can even see things like version numbers of the service. So if I want to provide an update to that service, I know what version number this is, and I can decide whether or not I want to apply that update. Now, I can see that within VMM, and that's great, but I want to see how that correlates with my management environment. And so I can, through Operations Manager, I can push the service template deployed from within VMM to Operations Manager through that Operations Manager connector. And what this allows me to do is create a distributed application inside of Operations Manager that shows the service, and it can expand out to see all the different tiers, and inside each of the different tiers see the different virtual machines that are deployed. And I can see how everything's running depending on each of the different tiers. And if one of these tiers is down or something's wrong with one of the different virtual machines, it'll bubble up to within Operations Manager inside of this environment here. And I can view it at the tier level, I can view it at the virtual machine level, or at the entire service level. And now everything's running fine and everything's great, but just like we had to update the Hyper-V hosts, we may have to update the services. Now, one of the cool things about the way the service template model works is that the service template is that basically that source of truth for the services deployed off of that template, which means that if I have an update, like I want to make a change to the application, go from version 1 to version 2, or I want to update the underlying operating system, apply a patch or something like that. If I apply it to the service template, I can then push it out to the deployed services and take advantage of the fact that these are going to look pretty much the same across all these different deployed instances. So the updates I do here are going to work for here, and the other places as well. So I can take a systematic approach to this service level updates. And I can do that by, taking an application or a service that's already deployed. I can update, say, the application inside of there, take that application package through server app v that's running version 1, upgrade to version 1.5 or 2 or whatever. I can then push that update to the service, and that service will then push that update down to the different virtual machines that are deployed inside of that tier. And I can do that for my applications, whether they're .NET applications, Java applications, using server app v, using my MS deploy, or my SQL environment. So like we said, to deploy this, the virtual machines are template driven, and they are managed through VMM. So basically what that means is that I have a couple of ways of performing these updates. Inside of VMM, I have this template with these multiple tiers. And if I make a change inside that template, I save it as a different version number. And then once I save it as a different version number, I can decide when I push that update down to that template, do I use in-place updates or image-based updates? If I use in-place updates, what's basically happening is I'm taking the virtual machine, I'm going to shut it down, make the change to that piece of it, whether it be an updated server app v package, an update MS deploy, whether it be giving it more RAM or whatever those changes are. It's not destructive, it just copies the updated files basically, or makes the changes to the files, then boots that virtual machine back up. If I do image-based updates, what we're going to do here is we're going to actually replace the VHD file. So why would I do that? Well, let's say I went from Server 2008 to Server 2008 R2. That's a pretty major update. And it might be more simple to, instead of running that update against each of the different VMs, to just replace the VHD from the old VHD file to the new VHD file and redeploy all the different applications, everything back on top of the environment. So we have both of these different types of updates. If we look at the first one and how it works with an image-based update, I basically have this template library where I create a service template. That service template has all the different parameters of the different tiers, and basically I can deploy a service from this set of tiers. Once I've deployed that service, I may want to make a change to one of the tiers. Maybe my app tier is running at 2 virtual CPUs and I want to run at 4 virtual CPUs each. Maybe the application version went from 1.0 to 1.5 and I want to deploy an updated app v package for that. Well, I can copy that existing service template, version it to a higher number, make the changes I want to make, and then save and publish that template. Once I've published that template, then all the services that are deployed against that template basically realize, hey, we're running an older version. So they're going to be set up there saying pending service update. And now I have the opportunity as an administrator to push this update down to the individual servers and services that are deployed as I see them and as I need to. And it'll apply the update. Now, if I'm using this thing called upgrade domains, then not only will it deploy that update down there, but by upgrade domains, it will actually only deploy to a certain number of VMs in a tier at a time until it cycles through them to get them updated. So if I have an application that can handle the fact that I have both version 1.0 and 1.5 running at the same time in that tier for a little while, as I'm doing this rolling update, basically, I don't want to shut everything down, lose all connectivity to the service, and then bring it back up, then through upgrade domains, I could bring down 1 server at a time or 2 servers at a time to get that update up and running. Probably more important with upgrade domains would be in a time where it's going to take a while to deploy, and that would be during, say, an image-based update, which basically follows the same steps that the first one did. I would create a VM template, and then after I create that VM template, I would deploy the virtual machines from there. I would deploy that service from that template, from the library. But now, instead of making a change to just a piece of that template, I'm going to change the VHD that service tier is running on. So I make a copy of that template, I pick the new service VHD that I'm going to deploy. At that point now I get the pending service update because I've published that template and set the new service to the new template. And then I can push that update down when I need to. And here, instead of doing the updates by just shutting down the VM, copying down the changes, bringing it back up or something like that, I'm replacing the VHD file, bumping that thing up to the new version of the operating system that's running on that, and now this thing's running at the version. And if I want to maintain service continuity and have limited downtime, I can use upgrade domains, as provided these applications can survive in this tier, will run properly if I have multiple different versions for a little while inside of there. And the nice thing is, if this is wrong and it doesn't work out, I can roll back to the existing version. I could roll from 1.5 back to 1.0. So what I'm going to do now is I'm going to walk you through some of these service template pieces inside of the demo. So let me pop back over to the demo screen here and get that up and running for you. So here we now have an environment where we can talk about the different service templates and stuff that we had. Now, if we look at the host environment, one of the things we talked about way early in this video, and I should have showed you this a few minutes ago, but instead I'll show you right now. We talked about dynamic optimization, and that's all done through managing the host group. You have the option here for dynamic optimization, which shows you the aggressiveness and the parameters that you want to use. It'll either inherit it from the parent or you'll be able to specify it yourself. But we've just talked about services, so let's pop over to the service templates within the library and show you what we're talking about there. So I have multiple service templates that are created already inside of here. I have a dev web service, a template that's running on Citrix, a new one that I've created, and each of these templates has a configuration on them. Those templates are created from leveraging VM templates that I already have. And I have a few VM templates that are created that have, in this example, I'm running a VM server 2012 R2 that's going to be hosted on Hyper-V. So if we look at this service template, this Contoso web service, if I right-click on it, I can open up the designer, and this is where I can see an existing service template. It's a single-tier template, but it has scale-out capability. So I have it right now. It's specified that this computer can be scaled out, default instance count of 1, maximum of 4, minimum of 1, meaning when I deploy this service, it will start and deploy 1. Once it's deployed and running, then I can right-click on it and hit expand or scale out, and I can scale it out to 2, 3, all the way up to a maximum of 4. This environment has the virtual hard disk, and it's using Windows Server 12 R2. It has the ability to create the virtual machine name, which is WS 2012 R2-star, and now I can add multiple things after that to give it a unique name inside of there. If I look at the properties of that virtual machine, I have the hardware configuration, which is it's running on Hyper-V. It has a certain number of processors and everything attached to it. I can specify the OS configuration, and here's where if I wanted to make changes, I could specify things like what features are attached to it. So I want .NET 3.5 installed on side of there, or maybe I want a specific role, like I want to enable the DHCP server role or something like that. I can specify those things, so when this service is deployed, those roles or features will automatically be created. It's joined to a domain, and I can specify all that information. I can either specify my own credentials or I can use a run as account. And by using a run as account, then I know that I have, if I change the password in the run as account, then the next time this uses it, it'll use the correct password and those types of things. And then I can add the application configuration or the SQL Server configuration. And here, if I wanted to add a new application, I can specify this, create a new application profile. I want to add a virtual application, and then I can browse what application packages I have. If I had any to deploy inside of there, I would be able to do that. Or maybe I don't want an application, but instead I want to add a web, an MS Deploy package. Well, again, as long as I have an MS Deploy package in my library, then I can leverage it and use it inside of this environment. Now, once I have these things configured out and created, and my network's set up and built, then I can deploy this service. And I can do it a couple ways. I could right-click on the service and say deploy, but since I'm in the designer, all I need to do is click Configure Deployment. It'll ask me for the name, and I'll call this Service 01. Which cloud do I want to deploy to? And I'm going to pick the management cloud this time. I'm going to say OK. And it's going to go through and build the environment. And for Service 01, I have one virtual machine. It's a Hyper-V virtual machine. It's going to give me a particular name when I refresh the preview. So I'm going to refresh the preview, and now we know that I can deploy it in this cloud. It says that it doesn't have a problem with it. It's going to start with 1. And at this point, I hit Deploy Service, and it's going to go off and start the deployment of that service. And it's either going to work or fail depending on whether or not it has connection to the right storage and everything. And I'll be able to see that happen. Now, service deployments take 10-15 minutes, so we'll see it come online over time. And if I look at the management cloud, we see that it's starting to deploy, but it may or may not be there yet. So those are information and connectivity for a service template. Now let's flip back to the presentation and talk about the architecture of the VMM environment. So we'll pop over here real quick, and now you'll be able to, we've talked about keeping this thing with day-to-day operations up and running. We've talked about service deployments and how all that works. And now what we're going to focus on is what does this underlying VMM architecture look like, and how can I architect my system to get the best utilization of the resources that I have. So if we look at the VMM architecture, you basically have the VMM management server that can be set up in either a single or an HA environment. If I have a single VMM server, it can be a physical node or it can be a virtual machine. If it's a virtual machine and it's on a Hyper-V cluster, then it can be live migrated between different nodes in that Hyper-V cluster. But we also have the ability for VMM itself to be a clustered resource. So I could take a physical node cluster and I could have an active passive environment where VMM is running on one node, and if that node goes down, it'll bring it up on the other node. And we've actually made some work inside of R2 so that if there were tasks and services and jobs that were running, we'll restart those jobs and bring them back up. Those are connected to a backend SQL server, and that's where VMM hosts all of its information at that SQL server. So again, you're going to want that SQL server to be highly available so that I don't lose my VMM environment if I lose my SQL server. The other thing is that you have a library server normally, which is going to store all the different VHD files, the application configurations, those general GCE scripts or those generic command execution scripts, your server app V packages, your SQL DAC packs. And those libraries could be either one library or multiple library servers. They could either be the VMM server or they can be different servers, depending on how you have it configured. And you access the VMM server either through the VMM console or through PowerShell access. Basically, the VMM console is just a PowerShell front end. Basically, everything that we do inside the VMM console can be done via PowerShell. And in fact, that's what we do. When we create a task inside of VMM, it creates the appropriate PowerShell commandlet, and then it pushes that down to the VMM server. So you can create your own PowerShell scripts. And in a lot of dialogues, what you'll see is a View Script button. You click that View Script button, and it'll show you exactly what we're going to run on the VMM server. Now, once you have VMM set up, you have storage and networking that you have configuration, but you also have your Hyper-V hosts that you're going to be managing. These are going to be either your Hyper-V hosts, I should say your hypervisor hosts that you're going to be managing. They could be Hyper-V, they could be VMware, which you have to manage through vCenter like we talked about in the first video, or Citrix Zen server environments. And that's pretty much all of it. Now, the other two pieces that we have inside of there are a WDS server and the WSUS server. Now, the WDS server is for that bare metal deployment, whether I'm bare metal deploying the Hyper-V servers or the scale-out file server clusters. And the WSUS server is used for that patching and updating of the Hyper-V hosts. And when you put all those things together, connection between all those different things, that's your VMM environment. That's the underlying physical architecture. Now again, VMM itself can be made highly available with the VMM server, and it's cluster aware so that I can create it as a clustered resource, and if it fails on one server, it'll bring it up on the other server. It's an active passive environment, but at least it's there, so you have the ability to have that cluster failover if you need it. Now, if you do that, then you will have to ensure that the key is kept inside of Active Directory, because if the key is kept on Hyper-V server or VMM server number 1 and that goes down, then obviously VMM server number 2 is not going to have the right keys. So you have to keep the keys inside of Active Directory. The other thing is that if a job is running when the server goes down, that job will fail, but we'll be able to restart automatically that failed job, because VMM realizes it was running, VMM went down because of the cluster failover. We'll bring it back up and we'll restart that job. All right, we also have that library, and there's some things you got to consider about the library. If you look at what the library does, is it stores file-based resources. It stores your virtual machine hard disk files, your VHD or VHDX files. It stores your virtual floppy disk, your ISO images, all the different scripts, whether you're using them for deploying virtual machines or for deploying the bare metal servers, and your driver files for that bare metal deployment, as well as your application server-v packages, your MS deploy packages, and your SQL DAC packs. It also stores the conglomeration, the configurations of bringing those things together. You know, a virtual hard disk plus a server-v package combined with the OS configuration and profiles brings and creates a VM template. And so it creates your virtual machine templates, your service templates, the profiles for both your virtual machines, your applications, your hardware, as well as for those bare metal deployment and those types of things. And a library is something that stores all this information together. And you can have multiple different libraries out there. And you can have replicated data between each of these libraries, or you can have equivalent objects between these libraries. Think about it this way. If I have a server over here and it's using this VHD file, which has all my production information and some extra production workloads and hardening, but I want to deploy that same service in my development environment over here, and that development environment, I don't need some of that hardening. Well, I could have an equivalent VHD object between those two libraries, so that if I deploy the service and it needs that type of VHD, it'll get it when it's deploying to production. It'll use the production VHD file, and it'll have all that hardening that was necessary inside of there. But when it does it in development, it won't have that hardening because it'll use the development VHD file. So I can create multiple different libraries out there, and each host group, you know, a library is associated to a single host group. So I'm able to then take that host group and pick which library that host group is going to use. And that's important too, because I may not want the library that's connected and running over in my New York environment to be the same library that my host group over in Seattle is using. So in this example, you know, I have a VMM server and I created a service template that could be deployed in either Seattle or in New York. Well, I'm going to store a copy of that that service template on the different libraries, but it's going to need a particular resource. And if that resource is only stored inside of the New York library, when I deploy to the New York branch, everything's fast. It's right there, so everything goes great. But if I have to deploy that same service to Seattle, well, there might be a problem because it might take forever to copy that VHD file from New York to Seattle, and that could be really, really slow. So some of the things that you want to do is you want to set up a library equivalency and use the Seattle branch to access the Seattle library server, and just make sure that that library item is copied and resource is copied across between both of those different library servers. So that's what we were talking about with this library object equivalency, and that resources in any physical library object can be put as equivalent across these multiple different library servers. They could be the exact same file, or they could be different files that are equivalent to each other depending on where they want to be deployed to. So this means that now my host can use the resource that's deployed closest to it, instead of having to go all the way across the globe to get one of these shared resources. The other nice thing is these service templates that I create, I can export them. And not only can I export the entire template, meaning not only the configuration information, but the VHD and all the GC, the generic scripts and the packages and everything, and bundle it as one thing. I could just export the metadata information for that service template, and then I could just import and attach the different pieces. So I can take a service template, I can export it, and when I import it into a new library or a new server or a different VMM environment, it will ask me, I have this resource here. Is this the right one? Yes, check off like that. But when there's a resource that necessarily may not be the right one, or doesn't know which resource to tag it to, then it'll ask you, hey, you need to pick the right one here. So maybe I name my VM networks CorpNet, and you named your VM networks HomeNet. Well, when I import this service template, it may look for a CorpNet, can't find it. So it says, hey, I have this network called CorpNet. What do you want to replace it with? And you pick HomeNet. And then all of a sudden now I can deploy the service template and everything's up and good. So what we've really done is that we've allowed you to take these virtual machines and build the correct library infrastructure that supports where you have your data centers. But also with that, we allow you to take a virtual machine service template that you may have, export it, copy it to a different VMM, import it over there, make all the tweaks and changes you need so that it'll function over there, and deploy that out. So inside of this talk today, we've talked about a bunch of things. We've talked about the day-to-day operation of VMM. How do I make sure that the virtual machines are up and running and getting the right allocation of resources by using things like dynamic optimization to rebalance that workload on the fly. Keep those VM hosts up to date with the updating capabilities, whether it's using VMM and the baselines that we have there, whether it's using Configuration Manager, or whether it's using cluster-aware updating. We also talked about service template model and how we can ensure that we deploy a consistent image of services across all these different systems. And then lastly, we talked about the architecture of VMM and how you want to create correct configurations that allow you to have optimized use of resources, whether it be different libraries in different locations, and how we can take those library objects and export them out and import them into a new VMM, say maybe at a host or a service provider or something like that, so I can deploy my resources up there. We talked about throughout the whole day things like, how do I deploy my compute, my storage, my networking resources? How do I build from this set of resources a private cloud and put them all together and manage across my on-premises cloud and maybe connect to a service provider and manage things over there? And the day-to-day operations like we talked about in a few seconds. So now the next step is to look at the evaluation software that we have out there. Download some of that evaluation software so that you can see what's going on and test these things out in your environment. Learn more about this by looking at all the other Virtual Academy sessions related to Windows Server 2012 R2 and System Center 2012 R2, and get certified. We have a great certification plan for you to understand how to better your career through Microsoft certification. And if you want, use our TechNet virtual labs that are online and try this out inside the online virtual labs. So with that, I thank you for your time today and appreciate everything. Listening to our sessions on deploying config as well as infrastructure provisioning for System Center 2012 and R2.